What's up, guys? I'm doing a video for you for the final prep. I want to help you get ready for the upcoming test. So this is part 10, and I want to walk you through it. The question says the region in the first quadrant between the curve y equals and the second curve y equals is rotated about the y-axis. So we're going to go ahead and quick sketch those curves and use some graphing utilities. So if you have like TI-83, iInspire, Desmos, although have a handheld device. We also need to know where the two curves cross. So I'm going to start by graphing using technology. Start by graphing the two equations, y equals 0.5x to the third and y equals negative x squared. One thing, make sure you use the correct negative symbol, not the minus sign. And then a little second trace 5 option lets us find the location. You don't have to actually move the cursor around. You can just guess it's near 2, and the calculator will do the rest of the work. I use thousands. Typical or standard is to use at least 3 decimals or more. So my location where the two lines cross is at 2.186, 5.22. We're rotating this around the y-axis. When you rotate things around the y-axis, that's making this vertical, like column, as it were. We need to write things in terms of x functions of y. So instead of saying y equals, you need to start by making it be an x equals function. Both of them have to be written as x equals functions. And so with some algebra, getting the x to be isolated in both cases, we wind up with these two equations. The equations, going back to take a look at the graph, they are split in how they approach their connection. So first of all, if you imagine that there's the curve y equals 0.5x to the third power, it's the dominant curve rotating around the y-axis. So we first of all need to pretend that we're going to find like the bottom half of this cone, and then we're going to use the other function to find the top half of the cone. The volume is what I'm referring to. I make a little minor mistake. Remember, your volume formula is pi r squared times h. So inside the integral, you have to square the function. That's your r squared. Your pi is a constant, so it can go on the outside of the integral. And then h is actually determined as you integrate from 0 to 5.222. They do the same thing for the other curve. That other curve goes from 5.222 up to 10. And don't forget, it's still volume is pi r squared, so you have to square the function and throw pi on the outside. Trying to show the steps that I used along the way. A little math fnint, option 9. And we can actually go ahead and calculate this. It's going to be a close estimate because we're not using the exact decimal intersection where the lines cross, but it'll do enough for your calculation and for the work. And now we're just going to plug it all in, get an answer back, and evaluate it to see what sort of result we have. I make a mistake here. I forget that I'm supposed to square the 2y to the 2/3 power. No, wait, I do that, don't I? Do I, don't I? I do. The 2 is the squaring portion. I think I forget to square this second integral, so that's a calculation mistake that I make along the way. I also inverted, because I was feeling lazy, I inverted my 10 and my 5.222. So it's not 21. The answer is not 47 plus 21, but it's close to it. In that the mistake that I forgot to make was square the square root. And so go back and take a look at that. Anyway, thanks for watching this video, and I hope it was kind of cleared up some things you need to do for revolutions of solids around an axis. I've got other videos that are lined up with Khan Academy, videos or tasks that do the same thing, so please feel free to check those out. Thanks for doing some math with me, and stay tuned. I got some more videos coming out. Thanks. Bye.